Deep within the Earth's crust lie elements unknown to most, yet vital to our modern world. These are the rare earth elements, a group of 17 metallic elements with unique magnetic and luminescent properties. Don't be fooled by the name rare. These elements are actually quite abundant. However, they are rarely found in concentrated, easily extractable forms. Rare earths are the hidden ingredients in countless technologies. They power our smartphones, computers, and televisions. They are essential for electric vehicle motors, wind turbines, and advanced weapons systems. Without rare earths, our world as we know it would grind to a halt. The unique properties of rare earths stem from their atomic structure. They possess electrons in their outer shells that can be easily excited, leading to their remarkable magnetic and luminescent behavior. This makes them indispensable for a vast array of technological applications. Despite their relatively low profile, rare earths play an outsized role in our lives. They are the unsung heroes of the digital age, silently enabling the technologies we rely upon every day. In the latter half of the 20th century, one nation rose to dominate the global rare earth market, China. Like a dragon awakening from a long slumber, China leveraged its vast natural resources and strategic planning to become the world's leading producer and exporter of these critical materials. China's journey to dominance began with its vast reserves. Estimates suggest that China holds over 1/3 of the world's known rare earth reserves. These deposits, concentrated primarily in Inner Mongolia and southern provinces, provided the raw materials for China's rise. But resources alone do not guarantee dominance. China's government played a pivotal role, implementing policies that encouraged domestic production and exports. Investment flowed into mining and processing facilities, while lax environmental regulations kept costs low. As the 20th century drew to a close, China had become the world's low-cost producer of rare earths. Western nations eager for cheaper alternatives shifted their production to China, unwittingly handing over control of this critical industry. China's dominance in the rare earth market wasn't merely a result of natural resource abundance. It was a calculated strategy, carefully crafted and implemented over decades. Key policies and actions played a pivotal role in cementing China's grip on this vital industry. By developing refining capabilities and implementing export quotas, China controlled the global supply chain. These strategic moves transformed China into a rare earth powerhouse. Section 4. The world reacts, navigating China's rare earth influence. China's dominance in the rare earth market sent ripples across the globe. Countries that had become reliant on Chinese exports found themselves vulnerable to supply disruptions and price fluctuations. The realization that a single nation held such sway over critical materials sparked concern and action. Japan, a major consumer of rare earths for its electronics and automotive industries, felt the pressure acutely. When China temporarily halted exports to Japan in 2010 amidst a diplomatic dispute, it served as a wake-up call for Tokyo. Japan, along with other nations, began to diversify its sources of rare earths, seeking alternative suppliers and investing in domestic production. The United States, once a major rare earth producer, had largely outsourced its industry to China. The strategic implications of this dependence became increasingly clear, prompting a renewed focus on domestic production. Efforts were made to reopen mines, develop new extraction technologies, and secure supply chains from allied nations. The European Union, heavily reliant on rare earths for its green technology ambitions, also recognized the need for diversification. The EU launched initiatives to promote research and development in rare earth recycling and substitution, aiming to reduce its reliance on Chinese imports. Section 5. Breaking the chains, global efforts to diversify supply. The realization of China's near monopoly on rare earth elements sparked a global scramble for alternative sources. Countries around the world, recognizing the vulnerability of relying on a single supplier, embarked on ambitious plans to diversify their supply chains and reduce their dependence on China. One approach involved identifying and developing new rare earth deposits outside of China. Countries like Australia, with its vast untapped resources, emerged as potential suppliers. Mining companies, spurred by rising demand and government incentives, invested heavily in exploration and development projects. Recycling emerged as another promising avenue for securing rare earth supplies. Researchers and companies developed innovative techniques to recover valuable elements from discarded electronics, batteries, and industrial waste. By tapping into this urban mine, countries could reduce their reliance on virgin materials and mitigate the environmental impact of mining. International collaboration became increasingly important as nations sought to pool resources and expertise. Joint ventures between governments and private companies aim to develop new mining technologies, establish processing facilities, and secure long-term supply contracts. Section 6. Innovation and Adaptation. Technological Advancements and Their Impact. The quest for rare earth independence also spurred a wave of technological innovation. Scientists and engineers, challenged to find alternatives to Chinese supplies, explored new frontiers in material science, extraction techniques, and manufacturing processes. One area of focus was the development of substitute materials. Researchers investigated ways to replace rare earths in certain applications with more readily available elements. While not always a perfect solution, these substitutes offered a potential way to reduce reliance on critical materials for specific technologies. Advancements in mining and processing technologies also played a crucial role. Companies developed more efficient and environmentally friendly methods for extracting rare earths from lower-grade ores, unlocking previously uneconomical resources. New separation techniques allowed for the recovery of specific rare earth elements with greater precision, reducing waste and improving efficiency. The manufacturing sector also witnessed significant innovation. Companies explored ways to reduce the amount of rare earths required in their products. Designs were optimized and manufacturing processes were refined to minimize material usage without sacrificing performance. Section 7. The Future of Rare Earths. A balancing act between cooperation and competition. As we look to the future of rare earths, one thing is clear: the landscape is shifting. China, while still a dominant player, faces increasing competition from other countries vying for a share of this critical market. The global race for rare earth security is a complex tapestry of cooperation, competition, and technological advancement. The world has learned a valuable lesson about the importance of supply chain resilience. No country wants to find itself at the mercy of another for essential materials. This realization has fueled a global push for diversification, innovation, and strategic partnerships. However, decoupling from China entirely is neither feasible nor desirable. China possesses vast reserves, established infrastructure, and expertise in rare earth production. Engaging with China constructively while fostering competition and reducing dependence will be crucial. The future of rare earths lies in finding a balance between cooperation and competition. By working together, we can ensure a stable and sustainable supply of these critical materials, while also fostering innovation and economic growth for all. The quest for rare earth security is a journey that demands collaboration, ingenuity, and a shared vision for a more sustainable future.